All right, in this video, what we are going to do is start going through our additional organic compounds other than just hydrocarbons. So hydrocarbons are organic compounds that contain only C's and H's, no oxygens, nitrogens, chlorine, anything like that. We're going to start working with compounds that contain things other than just C's and H's. So we are going to be working now with table R on page 8 of your reference table. So we have some other types of organic compounds such as halides, alcohols, ethers, aldehydes, and so on. And we're going to start going through those today. The principles that we already learned still apply. Like, first thing you do is see how many carbon atoms you have, and then that gives you your prefix, like 5 carbons is pent, and so on. The first group that we are going to look at today is the first one that is on table R, and those are halides or halocarbons. So what we have is a halogen, which is a group 17 element added on to our hydrocarbon. So we are going to name them just like we would name a normal hydrocarbon, and then we are going to insert the name of the halide. So that would be fluoro, chloro, bromo, ido there for which halogen we have. And then we will also use a number out in front to indicate the location of it. Just like when we named our branches, if we happen to have 2 fluorines coming off, then we wouldn't say fluoro, we would do difluoro. All right, so our first example is going to be 2-bromobutane. So we do the same thing where we start at the end of the name specifically with how many carbon atoms you have. So the prefix but tells us we have 4 carbon atoms, and ane tells us we have single bonds. So that would be butane. Then we have bromo. Bromo tells us that we have a bromine atom, and that bromine atom is going to come off of the second carbon. So off of the second carbon, we have a bromine, and that's all that we have happening. So now we just go back and we add in the appropriate number of H's so that all of the carbon atoms get 4 bonds. Bromine does not get any H's because bromine has 7 valence electrons, so it makes just 1 bond. So bromine is all set there. Okay, next one. All right, we have 1,3-dichloropentane. So we start at the end with pentane. Pent means 5 carbon atoms, so we draw our 5 carbon atoms. Then ane tells us that those 5 carbon atoms are connected with single bonds. All right, then we see chloro. Chloro means we have chlorine. Di means that we have 2 chlorines, and they come off of the first and the third carbon. So off of the first carbon we have a chlorine, off of the third carbon we have a chlorine. Then we go back, we add in enough H's so that all of my carbon atoms have 4 bonds total. The chlorines do not get any hydrogen atoms because the chlorines have 7 valence electrons, so they only make 1 bond. If I needed to do the molecular formula for this one, the molecular formula would be C5H10Cl2. So you would insert the chlorines at the end of it. One other thing that I want to talk about is how nice it is to have the example written on the reference table for us. So we don't really have to memorize how to name them. We use this example here and then adjust it. So they gave us the example of 2-chloropropane. So if we had fluorine on there, we wouldn't call it chloropropane, it would be fluoro. And this has 3 carbon atoms, hence why we have prop. So if we had 8 carbon atoms, it would be octane. So you use your example and then you just modify it as necessary to fit what you have. All right, our next group on table R are alcohols. Alcohols have the OH group. And then the second bullet here, alcohols are not bases. Hopefully you remember from the acid-base unit that bases have the hydroxide ion. And it's that hydroxide ion that gives it its high pH and its basic properties. Alcohols are not ionic, so that OH stays on the compound. We don't have the OH ion in solution, so therefore alcohols would not be basic. All right, in order to name them, we follow our example. So the example given on here is 1-propanol. So the way that we name our alcohols is we name our hydrocarbon like we normally would. You replace the final E with OL for alcohol. And then you may also need a number to indicate where that OH group is. All right, so our first example, 1-methanol. So meth, 1 carbon. OL tells us an alcohol. So we have the OH group coming off of that carbon. Now when you draw the OH group, you can leave it OH or you can show the bond between the O and the H. Either way, that's fine. There is obviously a bond there between the O and the H, otherwise it wouldn't stick together. Then you go back, you add in your H's. So this would be CH3OH. You could also write the formula as CH4O, but this is the preferred way because it keeps the OH group together, and so that helps us recognize that it is an alcohol. Oxygen has 6 valence electrons, so it only gets the 2 bonds. All right, our next one, 2-propanol. We start with how many carbon atoms? So prop is 3 carbon atoms. AN, they are connected with single bonds. OL, that tells us we have an alcohol, so we have our OH group, and it comes off of the second carbon. Then you go back, you add your H's. For the formula, I would write it as C3H7OH. Again, leaving that OH together to help show that it's an alcohol. You would be correct, though, if you did C3H8O. We have 3 different types of alcohols: monohydroxy, dihydroxy, and trihydroxy. And that correlates to 1OH, 2OH, 3OH groups. So a couple of examples on each of those. So monohydroxy, we have the 1OH group present. So if we draw out ethanol, F is 2 carbons, 1, 2. AN tells us single bond. OL tells us we have an alcohol. We could put it on either carbon because technically either carbon is carbon number 1. So it doesn't matter where you draw it. And it also doesn't matter if you do O-H or OH. Then you go back, you add in your H's. Oxygen does not get any H's because oxygen has 6 valence electrons. So therefore oxygen makes 2 bonds. Okay, number 2, 2-pentanol. Start with the number of carbon atoms. Pent is 5. So we have 5 carbon atoms. AN tells us that they are connected with single bonds. OL tells us we have an alcohol, and that alcohol group comes off of the second carbon. So you can point it up, point it down, doesn't matter. And then after that, you just have to add your H's. All right, in a diol, we have two OH groups present. So 1, 2, ethane diol. Start with how many carbon atoms? Eth is 2. Connect them with single bonds because of the ane. Diol. OL tells us alcohol. Di tells us we have 2 alcohol groups. 1 on carbon 1 on carbon 2, and then add in the rest of your H's. All right, a triol means that we have a trihydroxy alcohol, meaning that we have 3 OH groups. So 1, 2, 3 propane triol. We start with the number of carbon atoms. Prop is 3. Ane, they're connected with single bonds. OL tells me I have an alcohol. Tri tells me I have 3 alcohol groups coming off of the first, second, and third carbon atoms. Then we go back, add enough H's so that my C's all have 4 bonds. Next group we have is organic acids. Organic acids have a C double bond O, OH on the end of a carbon chain. And the way that we are going to name them, again, we're going to follow this example here. So that example is propanoic acid. So if we have 1 carbon, it would be methanoic acid. 2 carbons would be ethanoic acid, and so on. So it's going to be the hydrocarbon, drop the final E, and add oic acid to the end. Organic acids will conduct electricity. That's important. Organic compounds generally do not conduct electricity unless you have an organic acid. So if you see a carbon, it's not going to conduct electricity unless it is an organic acid. So it would say something like propanoic acid. You would see the C double bond O OH on it, or the formula would end with that Cu, and then you would know it's an organic acid. It's an acid, so it would have a low pH, and it would conduct electricity. All right, so in our examples, we are first going to draw ethanoic acid. So it should be very easy to recognize that we have the organic acid. So you have to have C double bond O, OH at the end. Just like with the alcohols, you can do OH or show the bond between the O and the H. Eth means we have a total of 2 carbons. We already drew 1, so you draw 1 more, and then add in your H's. The formula, I would do it as CH3COOH to keep that Cu organic acid group together. Your formula would also be correct if you did C2H4O2. All right, our next one, butanoic acid. Butanoic acid, again, we have to have the C double bond O OH group at the end of our carbon chain. Bute is 4 carbons. We already have 1. So we add in 3 more so that we have a total of 4 C's. Then we add the appropriate number of H's. So that would be butanoic acid. Next group we have is aldehydes. Aldehydes have the C double bond O H group. So these sometimes can get confused with organic acids. Organic acids were C double bond O OH. This is just H there. Aldehydes do have to have the double bond O group at the end of the carbon chain, otherwise it wouldn't be followed by an H. In order to name it, again, follow your example on here. So this is propanal. So you're going to name the carbon chain like you normally would, drop the final E, add Al for aldehyde. So ethanal, we have 2 carbons, AN connected with single bonds. Al tells us I have an aldehyde group on the end, so double bond O, followed by an H. Then you go back, add in any H's necessary. This O here does not need any H's because it already has 4 bonds total. The oxygen doesn't need any H's because it's got the 2 bonds that it needs. All right, propanal, we got 3 carbons, 4 prop, single bonds because the AN, aldehyde group, the double bond O has to go on the end. So you could do either end, the left or the right. That doesn't make a difference because they both are the end. And then H is on the middle one, and whichever end you did not put the double bond O on. Formula, you could write it a couple of ways. For this one, you could do C2H5CHO to signify your aldehyde, or you could do C3H6O. Either way is fine. All right, a ketone has the double bond O on an inside carbon. So our smallest ketone that we have is 3 carbons. So the double bond O has to go on an inside. If it goes on the outside, it would be followed by the H, then it would be an aldehyde. In order to name it, you follow that example there. 2-pentanone. So you name it like normal, drop the final E, and add -one for ketone. All right, so first example, propanone. Propanone, we got 3 carbons, single bonds, and -one for ketone. Now they didn't give me a number out in front of where my double bond O goes, but it has to go here on this middle carbon because that's the only one that's an inside carbon. If it went on one of the outsides, then it would be an aldehyde. Then you go back, add in enough H's. Middle carbon does not get any H's because it already has 4 bonds. And oxygen doesn't get any H's because it already has the 2 bonds that it needs. Formula, you could just do C3H6O. All right, 2-butanone. We have 4 carbons for but, single bonds for the AN. -one tells me it's a ketone, so I have to have a double bond O on an inside carbon. The 2 also helped me with that. Then you add your H's. Remember, every carbon atom has to have 4 bonds in order to be stable because it's got 4 valence electrons. And there we go. All right, ethers have a single bond O in the middle of the carbon chain. So they kind of break up the carbon chain. So we'll have a couple of C's, O, a couple more C's. In order to name them, we follow this example, methyl ethyl ether. So you name them both as branches and then add the word ether to the end. So diethyl ether has an O in the middle, carbons on either side. F is 2 carbons. So I know I have 2 carbons on either side. And again, instead of saying ethyl ether, it's diethyl ether. When you do the H's, remember oxygen has 6 valence electrons, so oxygen just gets 2 bonds, so oxygen is all set with the 2 bonds. It does not get any H's. Our next example is ethyl methyl ether. You also could have named this methyl ethyl ether. It doesn't matter what order they go in. So ether, we have O in the middle, C's on either side. So ethyl is 2 carbons. You can add it to either side, doesn't matter. Methyl is 1 carbon, add that to the other side, and then put your H's on